Hey there, welcome to Ontario Math, and today we are going to talk about probability. We love probability. Why? Well, if we understand probability, it'll help us figure out the likelihood of an event happening. And this is especially great when playing games. And we all like to play games, and the more you know about probability, the better of a chance you will have to win or lose, I guess, at a game. It's not just games, though. I mean, if you watch the weather forecast and they tell you that there is a 90% chance it's going to rain, well, understanding that probability of 90% chance that it's going to rain, it's going to be very likely it's going to rain, so you better pack an umbrella for the day. So kicking right into it, we'll take a look at the left over here, and it just goes through some of the words that help describe how probable, with the likelihood of the event happening. So if there are 0 favorable outcomes, and we'll talk about that later, if there's no outcomes that it can be, it's impossible. It's never going to happen no matter what in whatever you're talking about. It goes to very unlikely, to equally likely, which means that the favorable outcomes are identical. It's like a 50-50 chance. To likely it's going to happen, to very likely, to certain. That means all outcomes are favorable, and it's 100% chance it's going to happen. So no game is 100. Well, very few games are 100% certain. So if they are 100%, then you better play that game. Now I put up here the idea of how to make a fraction for probability. So the fraction, I always start at the bottom, actually. I always start at the denominator here. So at the denominator, we figure out the total possible outcomes, okay, and we put it at the bottom. And the numerator is the favorable or targeted outcomes at the top all the time. Okay, so let's talk about how we can use this. So say we placed these chips in a bag, okay? We'll look at the first one right here. And we want to figure out what the probability is of choosing pink or green if they're all in a bag. So let's figure it out as a fraction and then try to say how likely it is to choose pink or green. So I want to make a fraction. So here we go. I'll put the line there. And my denominator is the total possible outcomes. So I have to find out how many total outcomes there are. In this case, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 total possible outcomes that we can choose. We can choose any one of those 10 in the bag. Now we want to talk about the favorable or targeted outcomes. So we're talking about pink in this case. So how many pink chips are there that we can pull? 1, 2, 3, 4, 5, 6. 6 out of 10. We can reduce this later, but I'm not going to get into that right now. And what are the odds? What's the probability that we're going to choose green? Well, again, there's still 10 possible outcomes. There's still 10 chips in there, except there are 1, 2, 3, 4 green. Okay, so I would say that pink, right, it's not equally likely, but it's more likely, it's likely that you can choose pink, and unlikely that you're going to choose green. But not by very much, though. It's pretty close to being 5 and 5, actually. Let's take a look at this one. Now, pretend we're adding 2 more chips into that bag. So now there are more chips in that bag. And that's going to affect our fraction right now. Because, again, the total possible outcomes now is not 10, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 chips. So our denominator now has to be 12 because there are 12 chips we can pull. In this case now, we're asking for how many green, what is the likelihood of choosing something green. So there are 1, 2, 3, 4 chips out of 12. So 4 out of 12. And what's the likelihood of choosing something red? Well, again, there are still 12 chips, 12 possible total outcomes. And how many are red in this case? Well, we can just see it's only the one there. Okay, so I would say 4 out of 12. Well, it's not equally likely, so I would say it's unlikely, right, that you'll choose green. And for red, I would say would be very unlikely because it's almost at 0 outcomes, right? It's only 1. That's as close as you can get to 0. So I would say 0 being impossible, 1 out of 12 would be very unlikely. You're not likely to choose that red chip, and if you are, man, you're one lucky person. And that's your intro to probability.